Time. What is it? Where does it begin? Where does it end? Before the Big Bang? Was there time? Orient? Will it have an end? When our solar system reaches its expiration, when we cease to exist, will there be time, independent of everything, of all of us, independent of space? Is it something that flows in a straight line? According to the fathers of classical physics, such as Galileo and Newton, yes. Time is absolute, unchanging, constant, and flows independently of everything. When you think of absolute time, the name Newton immediately comes to mind. But, do you remember that young man working in a patent office in Bern? Do you know what he once wrote in his journal? Newton, I am so sorry. Newton, Descartes, Galileo, Maxwell, and dozens of other scientists. These names that changed history. With that one sentence, he was almost throwing a diss at all of them. Gentlemen, I'm sorry, but it's not like that. Our rebellious young man. Albert Einstein. Someone who, as a student, said, I don't care about this phenomenon or that phenomenon. I want to understand the way God thinks. The rest is detail for me. A man who, even an hour before his death, was holding his notebook and pen, trying to take the final step needed to solve the mind of God, to write the theory of everything. We'll talk a lot about Einstein. A lot. With all his merits and faults. With everything about him. I have so much material about this man's life and perspective. But today, we're going to talk about time. And to understand and explain time, we need to go back in time, to where it all began. Don't worry, we won't go back to Greek mythology or the philosophers of ancient times. Aristotle, Copernicus, all thought deeply about this subject. We can discuss them if needed, but let's focus on when the concept of time was first scientifically studied. Let's travel back to the 16th century. What a century it was, right? Galileo, Newton, Barrow, Descartes, an age of enlightenment that extends into the 17th century, and humanity first began studying time with Galileo Galilei. With Isaac Barrow and Isaac Newton, the concept of time almost took its final form, which would be accepted for centuries. For all these scientists, time, as we mentioned earlier, was absolute and universal. This concept of time is also known as Newtonian time, and this absolute concept of time was something constant, moving at a fixed rate in every part of the universe, measurable but not perceivable. Newton believed that time and space were entirely separate components of objective reality. And he believed that even if everything in the universe disappeared, time would continue to exist on its own. What did Shakespeare say? All the world's a stage. And for Newton, the one unchanging thing on this stage was time. Time was the one constant he didn't touch while describing the world-changing laws of gravity and motion. That's why we said at the end of the last video, there was a problem. A problem Newton couldn't solve during his lifetime. A problem he thought was God's work and something we couldn't fully perceive. The most obvious evidence of this problem lay in the orbit of Mercury in our solar system. Newton's laws could calculate everything, from the movement of an apple to the orbit of Earth, perfectly. But Mercury's orbit never quite fit the calculations. There was a constant deviation in its orbit. This is where he said, it must be God's work. Some scientists even speculated there must be another unseen planet, which they named Vulcan, to explain this anomaly in Mercury's orbit due to gravitational effects. But there was no such planet. None. Nada. There was no explanation for Mercury's defiance of all the laws, and as long as time remained constant, there wouldn't be. Now I'm going to ask something of you. Something very difficult. I know. But I want you to forget everything you know about time. Forget how time passes, how it flows in a straight line, how we live our lives as a line between birth and death, how time is the same for everyone, regardless of where or how they live. Forget it all, because we need to completely dismantle this perception, because it's wrong. All of it is wrong. Who says this? First, Wilhelm Leibniz says this. For Leibniz, there were events that occurred before, after, or simultaneously with one another. Time was merely the way our minds organized these relationships. Then, from a more philosophical perspective, Immanuel Kant joined in. Immanuel Kant argued that time was not something that existed on its own, nor was it a sequence of relationships between independently existing things. According to Kant, time was simply the way our minds organized our experiences. He proposed that things existing outside our minds and independent of us were not actually in time. But Albert Einstein would be the one to put an end to all these discussions.
In 1905, known as the Annus Mirabilis, miraculous year, of physics, Einstein published 4 incredible papers, including the special theory of relativity. Later, after more than a decade of intensive work, he published the general theory of relativity, engraving his name in history forever. These are not concepts to be explained in a single sentence, and we will delve deeply into them later. But let's not lose focus. We were talking about time. What is time? This question, which puzzled Newton's admirer Einstein the most, because after seeing Maxwell's equations, Einstein was convinced of one thing. The only constant in the universe was the speed of light. Regardless of your perspective or position, the speed of light remained constant, moving at the same rate. This meant something in Newton's laws had to change. Something couldn't remain constant, especially time. Time couldn't be constant. Let's move forward with an example. A catastrophic scenario. A scenario where the sun suddenly disappears. One day, without us noticing beforehand, the sun ceases to exist. If we analyze this scenario with Newton's law of gravity, here's what would happen. Earth would immediately veer off its orbit and drift into the vacuum of space. Instantly. Because according to Newton's law of gravity, it's as if there's a rope between two gravitationally attracted objects. It's like the larger object is reaching out and holding on to the smaller one. A fixed and instantaneous force. But according to Einstein, this is impossible, because the only constant in the universe is the speed of light, and nothing can exceed it. The speed of light is our universal limit, and it takes approximately 8 minutes for sunlight to reach Earth. Since the force of gravity travels at the speed of light, if the sun were to disappear right now, we would continue to live as if nothing had happened for 8 minutes. After that, well, that scenario isn't very pleasant. We'll discuss it another time. This discovery was one of the most significant in the history of science. And here's the strange part. We could have lived our lives just fine with Newton's laws. We wouldn't have even noticed, because this isn't something perceivable in our daily lives. Newton could calculate the movements of celestial bodies in our solar system with 99% accuracy, as far as our everyday understanding was concerned. But that 1% that didn't matter to us was a problem for people like Einstein, and everything had to have an explanation. Einstein. How did he arrive at this conclusion? Einstein realized this when he was 16. Einstein's thought experiments are famous. He could visualize any scenario in his mind and search for answers. At 16, he imagined a thought experiment involving a train and 2 people. One person was inside the train, and the other was outside, watching the train. The train was moving at an incredibly high speed.